For this lesson, we're going to start using the distributive property to factor each of our polynomials. And when I start to use the distributive property, I am going to relate that back to our greatest common factors. So let's take a look at this first example. I have 27y squared plus 18y. And so I need to think, what is the greatest common factor? So what is my greatest common factor? And that actually is a 9y is my greatest common factor. And so I'm going to distribute a 9y out of this polynomial. So I know that 27y squared plus 18y can equal 9y times, and if I pulled a 9y out, well, what am I left with when I pull that out of that 27y squared? Well, I'm left with a 3y plus 2. And I could check that by saying, okay, if I was to distribute this 9y to both of those terms, I would get a 27y squared plus 18. So whenever I can use the distributive property forward, and forward would be considered like this, or I can use it backwards to kind of factor out a term. So let's go ahead and look at this example. I have negative 2a squared minus 8ab squared plus 2ab. So we need to think, okay, what is my greatest common factor? And that greatest common factor is a 2ab. So now I'm going to factor out a 2ab from all of my terms. So I'm going to get 2ab times negative 2a minus 4a or 4b plus 1. And when I go to check to make sure that I have factored out correctly, I see that I would get negative 4a squared times b minus 8ab squared plus 2ab. So go ahead and pause the video, and I want you to try this one on your own. So when I look at what is the greatest common factor of this polynomial, I see that the only really greatest common factor that I have is a u and a t. So when I go ahead and factor out a u and a t, I'm going to be left with ut times 7ut plus 3t minus 1. And if I was to distribute that ut to each of my terms, I would get a 7u squared t squared plus 21ut squared minus ut. There is a method to help us factor polynomials, and that's called our grouping method. And the grouping method just allows me to group my original polynomial into terms that have common factors. So if I take a look at the 4qr plus 8r plus 3q plus 6, I see that 4qr plus 8r have a greatest common factor of 4r, and I see that the 3q plus 6 would have a greatest common factor of 3. So I can use parentheses to regroup my original polynomial. And when I factor out their greatest common factors, I'm going to get that 4r, parentheses, and then I'm just left with a q plus 2 plus 3 times q plus 2. And this is a really important moment, is noticing that what's inside the parentheses both equal the same thing. And you know that you've grouped your polynomial and your terms correctly when both of those come out to be the same expression. So you want whatever's in the parentheses to be the same expression. And now I'm just left with the q plus 2. And I need to figure out what am I going to do with this 4r and the 3? Well, I have a 4r plus 3. And so I'm going to put what's on the outside of that parentheses in its own parentheses. So I'm left with 4r plus 3, and that would be my final answer. So for this example, we're going to use the grouping method. And sometimes I'm going to have to rewrite the expression so that my grouping method will work. So I'm going to rewrite my expression to say Rn minus R plus 5n minus 5. And the first thing that I want to do is because I want to group, I'm going to put things in parentheses. And so when I look at this first half, I see that I can factor out an r, so I'm left with r and then n minus 1, because when I factor out an r, all I'm left with is a 1, and then I'm going to add, and then on my second one, I can factor out a 5, so I'm left with, again, n minus 1. And now, following the same way that we did our last example, I'm going to have r plus 5 plus, or actually times, the n minus 1. And I was able to get to that step because both of my inside of my parentheses equal the same thing. For this example, I'm still going to use my grouping method. And my grouping method, I see that I can use the 2mk minus 12m plus 42 minus 7k. And for my first term, I can factor out a 2m, and I'm left with k minus 6. And then I have plus, and I can factor out a 7, so I'm left with 7 and then 6 minus 1k. And I notice automatically that I do not have the same term inside my parentheses. I actually have a negative k on one and a positive k on the other. So I can then, again, factor out a negative 1 from this one. And you could always factor out a 1 or a negative 1 to help change your signs. So I have 2m times k minus 6 plus, and I have 7, and then in parentheses I factored out that negative 1, and now I have a k minus 6. So both of them match now. And I just need to simplify, so I have 2m k minus 6 minus 7, because a 7 times negative 1 equals negative 7. And then I have k minus 6. And I'll still follow my same rules. And I'm just going to combine what's on my outside of my parentheses. So I have 2m minus 7. And then k minus 6. I want you to pause the video and I want you to try this one on your own. So the first thing that we're going to do is we're going to group. And when I factor out, I'm going to factor out a c. So I have c times 1 minus 2d plus, and then on my second one, I'm going to factor out a 4. So I have 4 and then 2d minus 1. And I can go ahead and factor out a negative 1, c times 1 minus 2d plus 4, and I factored out that negative 1. So I have a negative 2d plus 1. And I'll get c times 1 minus 2d plus a negative 4 times negative 2d plus 1. Both of my inside my parentheses match. So I have c minus 4 times 1 minus 2d. Now we're at the point where we can start solving in a polynomial. And when I solve for that polynomial, since it's set equal to 0, I am just going to say, okay, well, each one of these terms that are in parentheses is set equal to 0. So I'm going to solve for the variable. And I also have the 3d minus 15 that could equal 0. So when I solve for both of those, I have that 2d equals negative 6, so d must equal negative 3, or 3d equals 15, and then d equals 5. D could equal 5. And when I check that, all I'm going to do is I'm going to put d in, or each number in for d. So when I substitute negative 3 in for d, I'm going to get 0. And when I substitute in 5 for d, I'm also going to get 0. So both of those actually work. For this example, I need to solve the polynomial to equal to 0. So to do that, I'm going to subtract a 3c from both sides. So I'm left with that c squared minus 3c equals 0. And I need two terms so that I can solve for, because I need two answers to find the roots. And to do that, I can distribute out a c. So I'm going to get c minus 3 equals 0. And now I can set both of these equal to 0. So c equals 0, or c minus 3 equals 0. So c can equal 0, or c can equal 3. Go ahead and pause the video, and I want you to try this one on your own. So you should have set both of these equal to 0, or n plus 2 equals 0. And when I divide by 3, I'm going to get that n equals 0, or n equals negative 2. Because to solve for this one, I would have subtracted 2 from both sides.